The maritime sector is undergoing rapid digitalization. Modern ships are filled with sensors, dashboards, and data streams measuring almost everything: structural loads, motions, machinery performance, and environmental conditions. Yet paradoxically, many operators report the same experience: more data, but less understanding. The core problem is that data alone does not create intelligence. Without physical meaning, context, and integration, sensor data quickly becomes noise rather than insight. This is why many so-called digital twins remain disconnected from reality, built as static models, updated infrequently, and ultimately not trusted in operational decision-making. When digitalization adds complexity without improving safety or reliability, it becomes an illusion of progress rather than real advancement. The real opportunity lies not in collecting more data, but in transforming data into actionable knowledge. This requires tightly coupling real-time sensing with physics-based digital twins, engineering models, and domain expertise. Only then can digital systems explain why something is happening, not just what is being measured. Only under these conditions does digitalization become a tool for safety, resilience, and informed decision-making, rather than a source of confusion. Taken together, the challenges we have discussed point to a deeper and more fundamental issue: the limitations of our current engineering philosophy. Despite the growing complexity and extended lifetimes of modern ships, we still rely heavily on inspection after damage, reactive maintenance, and component-by-component thinking. This approach is increasingly misaligned with how ships actually operate, as long-life, tightly coupled socio-technical systems. What is required is a paradigm shift from inspection to healthcare. Just as in modern medicine, the objective is no longer to respond to failure after it occurs, but to maintain health proactively through continuous monitoring, diagnosis, and early intervention. This shift also demands a move from reactive to predictive engineering, where emerging risks are identified and managed before they escalate into incidents or accidents. It requires abandoning isolated component thinking in favor of understanding ships as integrated ecosystems, where physical structures, machinery, digital systems, human operators, and the environment continuously interact. Crucially, this new philosophy does not replace traditional engineering. It extends and elevates it. It builds upon established design, analysis, and safety principles, while enabling them to operate effectively in a world defined by uncertainty, aging, and digital complexity. This is the foundation of the transformative framework I will introduce next: digital healthcare engineering.